Is life possible anywhere other than our home planet? And what if we tell you that there is a place within the solar system where we can find an ocean full of water twice as large as any of Earth's oceans? This ocean is hidden under a layer of ice dozens of miles in thickness. However, 125-mile geysers push their way up from under this ice shield, and the atmosphere of this world consists of oxygen. Sounds familiar, doesn't it? That's why today, we'll tell you about a place that's almost literally in our backyard, right in the solar system. We are heading to Jupiter to discover the depths of its icy moon, Europa. Europa is one of Jupiter's 7 satellites. It was discovered in 1610 by the famous astronomer Galileo Galilei, along with 3 other satellites that are now referred to as the Galilean satellites. Back then, this discovery made a lot of noise, but even to this day, that location remains one of the focal points of interest for scientists worldwide, from astrophysicists to biochemists. Jupiter and its satellites are now referred to by scientists as the miniature solar system, and there's a good reason for that. Each satellite has unique characteristics, from volcanic activity on Io to methane lakes on Ganymede. There's plenty to study on each moon. These satellites are still the center of attention, which is why, in just a few weeks, a new mission titled JUICE is going to head towards Jupiter, with the primary objective to observe and study the icy moons of Jupiter. We're already used to the fact that whenever we find water on our planet, we also find life. It is in search of water that the JUICE mission will set off on its journey to the icy surface of Europa and its siblings. But is water the only thing required for life to exist? We can't accurately estimate the conditions for life to actually exist in the universe. But there is one set of conditions that we believe leads to life flourishing in its many forms and sizes, and that is the conditions on our planet Earth. So, what conditions are these? Water is the #1 ingredient among the list of ingredients required for life, as we know it to exist, includes the need to dissolve and supply nutrients to organisms, while also allowing the waste products of these processes to be disposed of. Many factors indicate there is water under the ice on Europa. One of them comes from a similar situation on Earth. It turns out the double ice ridges and cracks visible on Jupiter's satellite are similar to those in Greenland. These irregularities are potential evidence of the existence of liquid water under this ice. On Earth, such ridges are caused precisely by the presence of water cushions within the ice and under these breaks, which gave the scientists the idea that these cracks are similar to the ones on Earth. As for the chemical elements necessary for the creation and maintenance of life, it turns out they are present on Europa. Satellite photographs taken by the Voyager probe make it possible to study the structure of ice and confirm that the ice is covered with a considerable amount of salt deposits and heavy metals, such as magnesium, which incidentally is the reason for the hue similar to the color of blood. We observe similar conditions on Earth and Greenland, where salt comes to the surface of the ice as a result of volcanic activity. On Europa, however, movements of ice strongly resemble tectonic activity, indicating they were possibly caused by it. The last ingredient we need is a source of energy. The sun, which is an energy source for our planet, can hardly be considered to have any real influence on Europa's ocean. Still, the ice covering this moon reflects a huge amount of sunlight, and the distance to the sun is 6 times greater than the distance from the sun to Earth. But the radiation exposure from Jupiter on each revolution around the planet is most likely the source of energy in question. The influence of Jupiter's radiation on the ice leads to the release of oxygen, which is what the atmosphere of Europa mainly consists of. Oxygen is the most important element in the organic chemistry processes on Earth. And if it somehow gets under the ice on Europa, it can become the fuel required for life to develop, even if it's just bacteria. It is also possible that on Europa, there are life forms that are not dependent on oxygen. The so-called anaerobic organisms exist on Earth, and in fact, in the early history of the planet, they were the dominant form of life. The last factor that's expected to be found through further study is the volcanic activity in the crust encircling the core of Europa. In the depths of our ocean, at the borders of continental plates, hydrothermal flows break out of the ground. If we take a closer look, we will see that the population around these places is incredibly high and includes some amazing life forms alongside various corals. It is believed that Europa's rotation around Jupiter causes the same processes at the bottom of the Moon's ocean. And if so, it is possible that life can be found near these hydrothermal zones. And so, we have all the necessary ingredients to create life. Surface. Now, see why we can so confidently claim the presence of these conditions. After the discovery of Europa and its relatives, the satellites Io, Ganymede, and Callisto, it took almost 400 years before the uniqueness of these Galileo satellites was revealed. In the 1960s, ground-based observation showed that Europa's surface was mostly frozen water, just like most other solid bodies in the outer solar system. At first, Europa seemed to be just an ordinary icy satellite. However, further research showed that the reflectivity of Europa's ice turned out to be incredibly high. This pointed to the fact that the ice was too clear and formed relatively recently. That was deemed unusual. To get to the bottom of it, scientists needed to get a closer look. They finally got that opportunity thanks to Voyager probes. They photographed the surfaces of Jupiter's moons in great detail, and it completely changed the scientists' perception of this moon. Indeed, Voyager's images show a surface brighter than that of the Earth's moon, dotted with numerous bands and ridges, with the surprising absence of large impact craters, tall cliffs, and mountains. In other words, a very smooth surface compared to other icy moons. Why was that surprising? Every object in the solar system is bombarded by meteorites, but on Europa, these traces are either incredibly faint or absent. What do you say to that? The researchers noted that some of the dark stripes have opposing sides that fit together very well, kind of like puzzle pieces. Furthermore, between these cracks, there was some dark icy material that seemed to flow into the cracks. This has made scientists speculate that the surface of this moon has been in active motion, at least recently. And so, the absence of large impact craters indicates that Europa's surface was relatively young. At the same time, this means that something had erased the traces of any impacts. There are two possible ways to explain this. As they escape from under the crust, the streams of ice erased the traces of the meteorite hits. Or the ice sank under its own weight, along with any traces of the impacts. In both cases, it means that the icy surface is very dynamic, almost like there's a warmer layer underneath. The scientists also found that the cracks they see do not match the predicted patterns that would form as a result of gravitational tides, as Europa orbits Jupiter. There was a missing piece of the puzzle. This led to a conclusion that Europa's ice crust was not so solid. It was determined that if Europa's surface moved independently of the inner layers, the patterns would match very well, which would be the case if there was a layer of liquid or slightly warmer ice between the surface and the depth. This spurred the scientists to learn more about Europa, and soon, they finally had an opportunity to do that. The Galileo probe was launched in 1989 and entered Jupiter's orbit in 1995. Galileo's main mission included observing each of Jupiter's 4 satellites during repeat flybys. The information sent by Galileo about Europa was so intriguing that the mission was extended to make a total of 12 close flybys near the icy moon. One of the most important pieces of data that caught scientists' attention showed that Jupiter's magnetic field collapses in the space around Europa. Scientists believe that the most likely reason for this magnetic anomaly was there is an ocean full of salt water under the icy surface of Europa. Only a large body of water would have such an effect. At this point, scientists were more than sure that there was an ocean on Europa. However, this was only the beginning. Exploring Europa got even more intriguing after some research of the Antarctic ice shelf. A new and truly stunning type of snow was discovered there, and it appears the same kind of snow could be falling on Europa. Surprisingly, it seems to fall upwards. How does it work? It's simple. The snow itself is lower in density than salt water, both in the Earth's oceans and on Europa. And the most amazing thing is that on Europa, due to the thickness of the ice, the snow most likely rises from the bottom up under the crust, possibly forming the same kind of mountains as on Earth, but upside down. The next thing hinting at activity under the ice were the geysers bursting from under the crust. Over the past 10 years, they've been recorded 3 times by scientists. These are bursts of ice reaching at least 125 miles in height, according to calculations. How does it happen? Scientists estimate that the depth of the ocean is about 35 to 65 miles, and the thickness of the ice crust above it is about 12 to 20 miles. It is precisely the relationship between the subglacial ocean and the ice lid during Europa's revolution around Jupiter, namely their friction and increasing temperature, that causes the ice to crack and display those cracks. Ice geysers periodically break out from the cracks, consisting of warmer ice or even water. One of these geysers was captured by Galileo. Unfortunately, there was no way to collect samples of this substance. At the same time, it is also important to point out, in the process of formation of such cracks, oxygen from above Europa's surface gets under the ice crust. This is yet another factor that speaks to the possible existence of life on Europa. And now that we've already formed a certain picture in our mind, we just need to wait, because, in addition to the mission that we mentioned earlier, there will be another journey, and it will be entirely dedicated to studying Europa Clipper. Europa Clipper, the mission, scheduled to launch in 2024. NASA has selected 9 scientific tools for a mission to Jupiter's moon Europa to determine definitively whether the icy moon could have conditions suited for life. The toolkit includes cameras and spectrometers for high-resolution imaging of Europa's surface and to determine its composition. This glimpse will not just show us a picture, will also make it possible to figure out exactly what we see. Another useful tool installed on the probe is a radar that will help to determine the thickness of the ice shell of the satellite and find underground lakes similar to those under the ice of Antarctica. A magnetometer on board measuring the strength and direction of Europa's magnetic field would allow scientists to determine the depth and the salinity of its ocean. The thermal equipment will scan Europa's surface for recent eruptions of warmer water, while the remaining tools will look for evidence of water and tiny particles in Europa's rarefied atmosphere. By collecting these samples, scientists will be able to study the satellite's chemical composition in more detail, painting a comprehensive picture of Europa as a whole. This will probably eliminate the need to drill through the ice and extract this information on the next mission. It is expected that once the probe reaches its destination and begins to revolve around Europa in 2030, the equipment will be able to do more than just understand the composition and structure of the moon in detail. After the Hubble telescope observed a water plume over the south pole of Europa in 2012, scientists hope that a new ice geyser will be detected during the flyby and that it will be possible to collect samples. The main purpose of the mission is to determine, over the course of the planned 45 to 50 flybys, if there are places under the ice crust of Europa where life could exist. The more detailed photographs of the satellite will allow scientists to select points of greatest interest for further observation. They plan to get as close as 25 miles from the surface. For comparison, the Galileo only managed to get 160 miles away from Europa. Of course, it would be nice to get closer, but the main obstacle for such a task is the incredibly harsh radiation field of Jupiter, which would not allow the probe to stay in its vicinity for a long time. Another problem with this study will be the lack of energy. There will be solar panels on the probe, but the distance from the source, the sun, will affect the performance of the system as well as its capabilities. But even those planned trips will be enough for a detailed study. Scientists are already planning another project to follow the Clipper mission and processing of the data it will collect. They want to land a robotic probe on Europa that will try to penetrate deeper into the ice. And perhaps that's when extraterrestrial life could be found. We just have to wait and look forward to new discoveries.